When we think of Saturn, the image that usually comes to mind is solitary and still. We picture a lone gas giant defined almost entirely by its iconic frozen rings. That picture changed as our detection technology improved. Saturn has overtaken Jupiter as the most moon-heavy planet in our solar system, governing a staggering swarm of 292 confirmed satellites. To find these new worlds, researchers rely on a digital technique called shift and add. Instead of taking a single photograph through a telescope, astronomers take dozens of long-exposure images of the space around Saturn. They shift those images to match the planet's motion across the sky, and then stack them together. This combined data amplifies faint signals, allowing tiny dots of light to emerge from the background noise. This graph shows the timeline of Saturnian moon discoveries, displaying an exponential spike between 2019 and 2026. By applying the shift and add method to archival telescope data, astronomers uncovered a population of tiny satellites that were once too dim to see. To understand how one planet governs an empire of almost 300 moons, we need to map out this territory. We have to take a spatial journey outward, starting deep within the rings and traveling to the absolute edge of Saturn's gravitational reach. When we look at the system from this perspective, Saturn acts as a miniature, fully functioning solar system, governed by distinct rules of orbital geography. Our journey starts in the innermost orbital zone, embedded directly within the icy debris of the main rings. Here, we find the shepherd runes, tiny, fast-moving objects that plow directly through the disk. Moons like Pan, Daphnis, and Prometheus use their gravity to push and pull on the surrounding ice. As they orbit, they sweep areas clean, carving out the sharp, distinct gaps visible in Saturn's rings. The orbital mechanics become more complex as we move slightly further out. We encounter Janus and Epimetheus, a pair of co-orbital moons that share the exact same path around the planet. This diagram illustrates their relationship. The inner moon travels slightly faster and catches up to the outer moon. Instead of crashing, their mutual gravity acts like a tether. The trailing moon gets pulled forward and flung into the higher orbit, while the leading moon slows down and drops into the lower orbit. Every 4 years, they swap places. In this inner zone, these bodies operate as mechanical gears, constantly grinding and sculpting the material of the rings. Pushing outward into the mid-range equatorial orbits, the geography shifts. We enter the territory of the 24 regular moons. These bodies formed natively from the primordial disk of gas and dust that originally surrounded Saturn. Because they grew alongside the planet, they all orbit neatly along its equator. The closest of these major moons is Mimas. It is an ice ball defined almost entirely by the massive Herschel impact crater, a scar from a collision that nearly shattered the moon to pieces. Next is Enceladus, a bright fractured sphere of ice. It holds a subsurface liquid water ocean, making it the smallest geologically active body currently known in our solar system. Deep space geysers erupt from fissures at its south pole, blasting water vapor and ice at over 100 kilograms per second. This frozen spray escapes the moon's gravity and supplies the material for Saturn's wide, diffuse E-ring. Further out sits the largest object in the entire system, Titan. At over 5,000 kilometers across, it is larger than the planet Mercury. Titan features a dense, nitrogen-rich atmosphere, hiding an Earth-like landscape. It is the only place besides our own world known to have weather systems that feed stable, liquid lakes on its surface, though here the rain is made of methane and ethane. Reaching the outer edge of this regular zone, we find Iapetus. It orbits 3.5 million kilometers away, and is split by a contrasting black and white surface. Its leading hemisphere is coated in pitch-black dust, while its trailing side remains bright white. These inner regular satellites possess a level of geological diversity and chemistry that rivals the planets of the inner solar system. They are native worlds. This map shows what happens when we zoom out millions of kilometers past Iapetus. The orderly blue disk of native moons is surrounded by a chaotic cloud. This is the outer zone, home to the remaining 268 irregular moons. Unlike the native moons that hug the equator in neat circles, these irregular bodies fly in on eccentric, elliptical trajectories. Their orbits are heavily inclined, cutting across the planetary plane at steep angles. Most of these outer satellites belong to the Norse group. They orbit in retrograde, meaning they travel in the opposite direction of Saturn's own rotation. This movement reveals their origin. They are not native to Saturn. They are wanderers, ancient icy centaurs from the Kuiper Belt that were caught in the gas giant's gravitational net. Once captured, their intersecting orbits made the outer system a dangerous place. The clusters of moons we see today, categorized into the Inuit, Gallic, and Norse groups, are the result of ancient collisions. Captured bodies were smashed apart into the dozens of fragments we observe today. This outer swarm operates as a gravitational graveyard, filled with the shattered remains of captured worlds. The architecture of this system suggests Saturn is more than a single planet. It's a gravitational engine that has been trapping, creating, and destroying matter for billions of years. The system is defined by its two extremes. Near the planet, native moons orbit in orderly, equatorial circles to sculpt the rings. Far on the fringes, the captured remnants of shattered asteroids drift backward in high, chaotic arcs. Because Saturn has held on to these two populations, its 292 moons serve as a physical record. They hold the evidence of the solar system's early history and the mechanics of orbital capture. By mapping the geography of these moons, we can see the physical processes of formation and capture that shape planetary systems across the galaxy.